Everything a computer does reduces to circuits making yes or no decisions, and a logic gate is the physical component that makes one. Each gate takes one or two inputs, each of which is a 1 or a 0. Remember that these are really high and low voltages, and produces exactly one output, again a 1 or a 0. There is no maybe. A gate is completely defined by its truth table, which lists every possible combination of inputs alongside the output that results. That word every matters. If a gate has two inputs, each can be 0 or 1, so there are 2 times 2, which is 4 possible combinations, and the truth table must show all 4. 3 inputs would give 8 rows. The syllabus limits you to a maximum of 3 inputs, so the largest table you will ever build has 8 rows. There are 6 gates to know: NOT, AND, OR, NAND, NOR, and XOR. Let us take them one at a time and reason out each table rather than memorizing it. NOT is the odd one out, because it is the only gate with a single input. It simply inverts whatever it is given. Its truth table therefore has only 2 rows, because a single input has only 2 possible states. If the input is 0, the output is 1. If the input is 1, the output is 0. That is the whole gate. It is sometimes called an inverter for that reason, and on a circuit diagram it is drawn as a triangle with a small circle on the output. That little circle is worth noticing now, because it is the symbol for inversion generally. You will see it again on NAND and NOR, and it always means the same thing. Whatever this output would have been, flip it. AND has 2 inputs and 1 output, and the rule is that the output is 1 only when both inputs are 1. Let us build the table properly. First row, A is 0 and B is 0. Neither is on, so the output is 0. Second row, A is 0 and B is 1. Only one of them is on, and AND demands both, so the output is still 0. Third row, A is 1 and B is 0. Again, only one is on, so 0. Fourth row, A is 1 and B is 1. Now both are on, so the output is 1. Notice the shape of that column, 3 zeros and then a single 1 at the bottom. A useful way to hold on to AND is the word both. If you can say both inputs are on, the answer is 1. In every other case, it is 0. OR is the mirror image. Its output is 1 when at least one input is 1. Building it, A 0 and B 0, nothing is on at all, so the output is 0. A 0 and B 1, one of them is on, and at least one is enough, so the output is 1. A 1 and B 0, same again, output 1. A 1 and B 1, both are on, which certainly satisfies at least 1, so the output is 1. So the OR column is a single 0 at the top and then 3 1s. Compare that with A and D, which was 3 zeros and a single 1 dash. They are exact opposites in shape, which is a useful check if you are ever unsure you have written the right table. NAND and NOR sound like new gates, but they are not. NAND is simply not AND. Work out the AND answer, then flip it. NOR is not OR. Work out the OR answer, then flip it. That is genuinely all there is to it, and it means you never have to memorize their tables separately. Here is NAND, and gave us 0, 0, 0, 1 going down the column. Flip every one of those, and NAND gives 1, 1, 1, 0. So NAND outputs 1 in every case except when both inputs are 1. NOR works the same way from OR. OR gave 0, 1, 1, 1. Flipping gives 1, 0, 0, 0. So NOR outputs 1 only when both inputs are 0. On a circuit diagram, both are drawn as the AND or OR shape with that small inversion circle on the output, the same circle we saw on NOT. XOR is the gate that costs students the most marks, so let us be careful with it. XOR stands for exclusive OR, and its output is 1 when the inputs are different from each other. Some people prefer to say exactly one input is on, which comes to the same thing for 2 inputs. Building it, 0 and 0 are the same as each other, so the output is 0. 0 and 1 are different, so the output is 1. 1 and 0 are different, output 1. And 1 and 1 are the same, so the output is 0. Now look carefully at where XOR and OR differ. They agree on the first 3 rows entirely. They differ on one row only, the bottom row, where both inputs are 1. OR says 1 because at least one input is on. XOR says 0 because the inputs are not different. That single row is the whole distinction, and it is the row examiner's test. You also need to recognize and draw the standard symbols, and is drawn as a shape flat on the left with a rounded right-hand end, or is curved on the left and comes to a point on the right. XOR is the OR shape with an extra curved line across its input side. NOT is a triangle with a circle. NAND and NOR are the AND and OR shapes with a circle added on the output. That circle is the thing to look for when reading a diagram. Spot it, and you know the output has been inverted. In written logic, you will also meet the algebra notation, a dot for AND, a plus for OR, and a bar or apostrophe for NOT. So A dot B means A and B, and a plus B means A or B, which can be confusing at first because that plus does not mean addition. 3 things to take into the exam. First, if you are asked to complete a truth table, fill in every row and generate the input combination systematically rather than at random. Count upwards in binary down the input columns, so 00011011. That guarantees you have all 4 and none repeated. Second, NOT is the only single input gate, and all the others are limited to 2 inputs at IGCSE. So if you find yourself drawing a 3-input AND gate, stop, because the syllabus does not allow it. Build it from 2 2-input gates instead. Third, the most common single error in this whole topic is confusing OR with XOR on the bottom row. Whenever you meet either of them, check that row deliberately. Is it 1 or is it 0? Getting that one cell right is often the difference between full marks and losing several.